On 7th grade students, let's talk about what we do for lab number 3. What we're going to do is we're going to figure out how high something is by measuring the time with a stopwatch. And I think I covered this with you when I was in a video before, but I used to do a lot of rock climbing. And one of the things that I would do is I would do cliff jumping, and I would jump off a cliff and figure out, and it was a lot of fun, and I would land in water and all of that kind of stuff. I'm not saying that everyone needs to go and do that, and make sure you guys are, back when I was super buff, but now I'm super fat. But back when I was cliff jumping and stuff like that, I'd always like to figure out exactly how long or how high from the cliff was that I was jumping off. You guys are asking me, shooting me, saying my name. Make sure you guys just email me questions if you guys have any questions, or ask me questions. But anyway, let me cover what I'm going to be going over for this lab. What you're going to need is a ruler, a meter stick, or some kind of measuring tape or something, and a stopwatch, and something to drop. And it could be anything. It could be a pen, a pencil, don't drop a baby brother, but drop a basketball or a tennis ball or soft rubber ball. And what I want you to do is I want you to hold the ball as high as you possibly can over your head. This is somebody, and they've got really long arms, and they're holding it as high as they possibly can. Okay? And they drop it. There we go. Drop the ball. Yeah, that's a horrible picture. I'm sorry. You're holding a ball as high as you possibly can over your head. And all you got to do is time how long it takes. Repeat this 5 times. So figure out how long it takes to fall to the ground. Fall to the ground, fall to the ground, fall to the ground. Isaiah, yes, you can check you can send me a private message. I haven't checked your private message because it will go onto the archive because I'm recording the screen that I'm looking at. So I don't want to check your private message on my thing, or else that would just be, rude, I think. But anyway, you measure the time it takes you for the ball to fall to the ground, and you just kind of take all the measurements and you average them. Got it? What is your measured time for trial 1? Okay, and this is where you put in all the answers. And this is where you take the average of that time. All right. Use your average time to figure out how high you drop the ball from. Now, look, check this out. Going back to this equation back here. Let me write down this equation right here. Okay? It says 2h0 equals g times t squared. That wasn't magic. I didn't pull it out of thin air. This actually came from the equation that we used before. All right. Let me get h all by itself. There's a 2 being multiplied by it. How do I get rid of that 2? If it's being multiplied, how do I get rid of the 2? Divide. Oh, okay, good. But I can't do it to just one side. I got to do it both sides, so I'm just going to put divide by 2. So I get h0 is equal to gt squared over 2. This, my friends, is the equation that you would use for this problem. So all you do is you take that time that you measured after you dropped it a bunch of times, and you plug that sucker into there. You square that time that you measured. So if you measured 3 seconds, you square that and you get 9. Then you multiply that by g, which is 9.81, and then you divide it by 2. And that's how high you are dropping this thing from. Does that make sense to you? It all really comes from this one equation. Everything that we've done so far really just comes from that. It's pretty amazing. So anyway, you just take your time and you plug it into there. You got to square your time that you measured. then multiply it by g, then multiply it by 1/2, and that's the height at which you drop the thing from. Then what I want you to do is measure, and that is actually how high your reach is, right? Because you held this thing above your head as high as you possibly can. So this would be the measurement of how tall you are plus the length of your arm. This is how high you can reach. And that's something that you measured. Got it? Then what I want you to do is actually measure how high you can possibly reach. I want you to get a string and hold it up as high as you can and measure how long the string is as it goes to the ground or something like that. Do you got that? Do you understand what question 8 is all about now? Or, whatever question this is. Yes or no? Okay, good. Then what I want you to do is find the difference between these measurements. Because this measurement up here, where I ask you to calculate out your initial height versus actually measuring it, might be different. It might, you might measure a different number, and that's what I want to know. Is I want to know what the difference is. And don't put a negative number, only put a positive number in there. Okay? And then the last question, I think, is find the percent error. So what you want to do is you want to take this number up here, the difference that you measured it, and divide it by the actual distance that you measured. So take question 9 and divide it by question 8. And then take your answer and multiply it by 100, and that will give you your percent error. That will tell you how far off your measurement was compared to how far off the actual answer is. Because in theory, question 8 is your actual answer. This is the actual value at which you dropped it. And I'll be honest with you, I expect the percent error, I expect there to actually be a difference because it's hard to measure things with a stopwatch. Does that make sense? Now, where could we find, where could this be really helpful? And I'm gonna finish in the next 2 minutes. But where could this be really helpful to our lives? Well, let me tell you this. What if somebody asked me to measure the height of a building? Now, obviously, what I wouldn't do is I wouldn't take a meter stick and measure out exactly how high that building was, right? I wouldn't take a ruler, a yardstick, or a string and drop it down the side of the building and measure it, or a tape measure for that matter. We're talking about a building here, my friend. But if I wanted to measure the height of a building, I could take a penny out of my pocket, go to the top of the building, drop it, time exactly how long it takes, and then from that I could tell you the height of the building using this equation. Does that make science cool again? Do you see what's going on here? Boy, it takes a lot to impress you. Well, that's fine. I have a lot more stuff I want to show you to impress you. Anyway, I want you to do these 2 labs, or these next couple of labs in this coming week. We're also going to have our bridge building stuff coming up. I'm going to end this recording, and I will answer any questions you guys might have, but you guys are free to go.